I have chosen the eye as the subject for consideration this evening for two reasons. First of all, it is an object that those people that believe in evolution and don't believe in a God say proves that God isn't the designer of the eye. It proves evolution. So we want to look at that. The other reason I want to look at the eye is because it's one of the few parts of sort of detailed parts of creation that God actually claims that he designed himself. And we've just read one of the two occurrences in the scripture where God says, you know, the eye, I designed that. Because there's another strand of people who would say, well, I believe God sort of started things off in terms of creation, but he sort of set the general parameters and then things sort of evolved from that starting point. But God says, no, I designed everything. I created everything, and even the detail like the eye, I was in charge of. I designed it. So we're going to look at something that God says, this is a hallmark of me. And what we're going to do as we look at the eye is be absolutely amazed and be full of wonder at the complexity and the detail and the thought that has gone into the design of the eye. So that's a little brief overview of the things that we're going to think about. But first of all, we're going to digress very briefly. Okay, so we haven't got an eye, we've got a picture of a ship. Who can tell me here what ship that is? Now, I thought I'll pick something that Gordon wouldn't know the answer to. But Gordon did know the answer to it. So it is the SS Great Britain. So anybody apart from Gordon, tell me what was special about the SS Great Britain? It's the first iron ship, yes, and it also had a propeller, a screw thread that propelled it, although it has got sails as well. And it was the first iron ship with a propeller that crossed the Atlantic. And it wasn't the first iron ship, but up to that time, almost all ships were made of wood. Now, you'll know that wood floats. Now, when you start saying, well, I'm going to build a ship and it's going to be made of iron, people obviously started straight away, that's not going to work because iron doesn't float. Brunel, who was the great designer, the great designer of many things in this country, said, no, I've worked out a way that I can get iron to float and I can build this ship and there will be these advantages of iron over wood, and I'm going to work with those advantages and I'm going to minimise the disadvantages of the iron. And that's what he did. In actual fact, the SS Great Britain wasn't a great commercial success because it had lots of problems that Brunel had to keep working on to iron out. But it demonstrates that a great designer doesn't always go for the most obvious solution to a problem. A great designer sits there and says, well, there's these things I want this design to do, and the sort of envelope or the brief of what I've got to do presents me with challenges. And I've got to overcome those. And the hallmark of a great designer is overcoming the challenges of the design in an elegant and an often beautiful way. And that's what we'll see with the eye. There are lots of challenges as to getting light into our bodies and interpreting and understanding that which is being picked up by the eye and transmitting it electronically to the brain. But God, in the design of the eye, has made a most complex and most beautiful structure. So, first of all, we're just going to think about the capabilities of the eye, because it is truly amazing. Even with modern cameras and things like that, the eye is still far better. The eye can see 40 or differentiate between 40 million different colours. Now, you've probably only got a very small sample on the screen today because the technology is not as good as our eyes. But 40 million colours, that's a massive number of colours that it can resolve. But the other thing about the eye is you can go out on a nice, bright, sunny day like today, and you can wander around and have no problems at all. But when it comes to night time, or when it's truly dark, that same eye will allow you to see a candle that is flickering 3.5 miles away. Think how little light that is compared to the bright noonday sun. And yet the eye is able to cope with those huge amounts of light and also those very tiny levels of light. all within that structure that's in a very small or two very small eye sockets in the front of our head. We think of megapixel cameras. If we try to sort of say, well, how many megapixels is the eye? It's about 126 million pixels, 126 million tiny little bits of information that are being picked up. And the view, the width that we can see, about 120 degrees. So far more than if we had even a wide-angle lens of a camera. 120 degree view is a very wide, we would call that a panoramic view. It's able to process the information at about 100 frames per second. So again, far higher than our standard video cameras process the information. So the eye is taking in lots and lots of information in very great detail. We can look at things that are just 0.35 of a mil apart from a meter's distance. A quick look around the room. Actually, they say needs more processing power than a supercomputer. You know, it's a fantastic amount of information that is processed. And because of that, the eye needs 3 times more blood flow to it per gram than your brain, than the cerebral cortex. There is a massive amount of information being processed within the eye, a huge amount of information then being sent to the brain. And it is really a wonder of engineering when we look at the eye. Now, those of you that did biology, you're probably familiar with that picture of the eye. You'll be very pleased that we're not going to look at everything on there tonight. We're only going to look at 2 little areas of the eye. We're going to look at the choroid and the retina, just those 2 that are highlighted. I could talk to you about lots of those other areas and give you lots of fascinating facts, but it would be dark by the time we leave, so you probably don't want me to do that. But these 2 little areas are what we're going to focus on. And for those of you who haven't been to a biology lesson for a little while, or maybe didn't choose biology, we'll just have a little biology lesson just to start us off, just so we know what we're talking about. So on the left-hand side, we can see the structure of the eye. So at the front, you've got the pupil, you've got the lens, the bits that we can see from the outside. And then inside the eye, at the back of the eye, you've got this area, the retina, that is photosensitive. The light is falling upon, the lens is focusing on to the retina at the back. And in the retina are the rods and the cones that we perhaps know about, and all sorts of other nerves and ganglion cells that are doing a very interesting and very amazing job within the eye itself. But I said to you that the evolutionists say that the eye proves that there isn't a designer. Now, why would that be? We need to just understand this before we can really understand their comments about the eye. So I've got 2 very simple diagrams here. Our human eye and the eye of mammals is what's called an inverted retina. So there's 2 sorts of retina, an inverted retina that we've got and a verted retina. Now you'll find a verted retina on some animals, so like octopus or octopi have a verted retina. So what's the difference? Well, with a verted retina you have the light sensitive part of the eye at the front facing into the light, and the wiring of the eye that takes that information to the brain is at the back. And that would seem a relatively logical way of doing things. But mammals' eyes and the human eyes are slightly different. They have this inverted retina, and that means that the wiring is actually at the front. So you can see the light source, and you can see the rods and the cones and the bits with the black dots, which are the light sensitive parts, and you can see that the wiring is actually in front of that. Now, on the face of it, that seems counterintuitive, isn't it? Why would you put the wiring at the front? And this is what the evolutionists pick up on and say, this shows that this can't have been designed. And we're going to have comments from 3 different people who are all well-known evolutionists. So the first one is Graham Phillips. I've got a succinct little quote from him, and he says, "No engineer worth his salt would design an eyeball the way that ours has been built." And that's quite a dismissive phrase, isn't it, really? Especially when we think about the capabilities that we've looked at with the eye. I mean, we don't normally wander around thinking, "Oh, these eyes that we've got, they're rubbish." But this gentleman here is saying, well, actually, if you're an engineer, you wouldn't have designed it this way. It's not up to scratch. Richard Dawkins makes quite a long comment on the eye in his book, The Blind Watchmaker. So he says that any engineer would naturally assume that the photocells would point towards the light, with their wires leading backwards towards the brain. He would laugh at any suggestion that the photocells might point away from the light, with their wires departing on the side nearest the light. Yet this is exactly what happens in all vertebrate eyes. Each photocell is, in effect, wired in backwards, with its wires sticking out of the side nearest the light. This means that the light, instead of being granted an unrestricted passage to the photocells, has to pass through a forest of connecting wires, presumably suffering at least some attenuation and distortion. And then he says, well, probably not much, but it's the principle that would offend any tiny-minded engineer. And this last set of quotes is from a gentleman called Kenneth Miller, and he titles it Design Flaws. He said, well, the eye is a design flaw. Because intelligent designs, that's people that believe that God is the creator. Because intelligent design works from a clean sheet of paper, it should produce organisms that have been optimally designed for the tasks they perform. Conversely, because evolution is confined to modifying existing structures, it wouldn't necessarily produce perfection. So which is it? Well, he says the eye, that supposed paragon of intelligent design, offers an answer. Photoreceptor cells located in the retina pass impulses to a series of interconnecting cells that eventually pass information to the cells of the optic nerve, which leads to the brain. An intelligent designer, working with the components of this wiring, would choose the orientation that produces the highest degree of visual quality. No one, for example, would suggest the neural connections should be placed at the front of the photoreceptor cells, thus blocking the light from reaching them, rather than blocking the retina. Now you can see their point, can't you, in the sense that, prima facie, when you think about it, it does seem strange that the wires would be in front of the photoreceptor cells. But as we shall discover when we think about the eye a little bit more, there are good reasons for that. And you remember when we talked about Isambard Kingdom Brunel and his iron ship, we said that a great designer has to take a load of competing challenges into consideration and has to design something that satisfies all those competing challenges to produce something that is the best way forward. And as we shall see, that is the same with the eye. Now I've got a comment, or a couple of comments now, from a gentleman who is a creationist. He worked, or did work, at Glasgow University, and he worked in the field of eye research. So I think he's a well-qualified person to tell us what he thinks of the eye and the reasons why the eye has been designed as it has. And I think these are from the Answers in Genesis website. There was an interview there. So the question is, what do you think about the eye, the idea that the eye is wired backwards? And he says, the notion that the eye has been wired backwards occurred to me when I was a 13-year-old studying eye anatomy at a school science class. It took me 2 years of lecturing on human eye anatomy to realise why the eye is wired the way it is. The idea that the eye is wired backwards comes from a lack of knowledge of eye function and anatomy. So what he's saying is, well, when you look at it on the surface, yes, it seems strange how the eye has been designed. But when you understand the detail, you will realise exactly why it has been designed in the way it has. So the next question was, how do you react to the notion that the human eye is a product of evolution? And he said, the more I study the human eye, the harder it is to believe that it is involved. Most people see the miracle of sight. I see the miracle of complexity on viewing things at 100,000 times magnification. It is the perfection of this complexity that causes me to balk at evolutionary theory. I think it's a very elegant phrase there, the perfection of this complexity. The eye has to do so much, so fast, to provide us with what we take for granted, the miracle of sight as he calls it. And yet he sees in there the detail of the processes that have to be gone through to provide for us what we take for granted every day. And he goes on to say the retina is probably the most complicated tissue in the whole body. Millions of nerve cells interconnect in a fantastic number of ways to form a miniature brain. Much of what the photoreceptors see is interpreted and processed by the retina long before it enters the brain. And that's one of the amazing things about the eye. The eye is in fact, or two brains that are taking the information that is falling on the eye and are processing it and interpreting it before it then sends information to the brain. And this was one of the things that puzzled scientists for a long time, because there is the optic nerve that takes the information to the brain, and they just couldn't understand how so much information could be passed through the optic nerve. And they eventually came to realise that the answer to their question was that a lot of the information is pre-processed in the eye before the information then, in a more succinct form, is passed to the brain to make sense of. So the eye is doing something amazing in a very small space over a very long period of time. So we're going to look at that in detail. So what I want to just think about first of all is, well, what does the eye need to do? And the eye needs to perform over a long period of time, doesn't it? I mean, on average, we might need glasses as we get a bit older, but on average, our eyes will last our lifetime. We have the amazing wonders of surgery that can mend cataracts and things like that. But the eye will more or less last us a lifetime. And actually the eye has a very hostile environment in which it works. The eyelids have to be open to see. There's all sorts of things that are being thrown at the eye, and it has to try and cope with keeping it clean, keeping it dust-free, preventing disease coming into those open channels. But also, what's coming into the eye, the thing that the eye is interested in, as well as light, is radiation, isn't it? Light radiation is harmful. You only have to think about what you do, if you're a child and you get a magnifying glass and sort of focus the sun's rays, you can very quickly start burning bits of wood or burning ants and things like that. Perhaps you didn't do that, Daphne, but light is a very powerful source of energy, and that's falling in our eyes and it's being focused on the back of our retina. So the eye has to cope with that, not just for a short time, but for years and years and years. And the eye has amazing mechanisms built into it that allow it to do so, and to give us such beautiful sight and beautiful ability to see colours and things at great distances and very close up. It is amazing what the eye can do. So we're going to look at the retina, just that little tiny bit of the eye. And we're going to first of all look at this area which is in the cream, or the sort of very light orange at the top, first of all. And this is where the wiring is that the evolutionists were busy thinking about. I'm busy saying this is a silly place to put the wiring. But it isn't actually just wires. There are all sorts of cells in there that process information. So you can see on there we've got the ganglion cells, and we've got the bipolar cells, and we've got the horizontal cells. They're all there in front of the eye, and they're all doing an important job. And when they've done their processing, then they pass the information up to the optic nerve to send it off to the brain. Now when you look at it on a diagram like that, it looks at a massive amount of structures that are in front of the rods and the cones, which are the bits down the bottom, which are actually the photosensitive bits. But in actual fact, in actuality, it's almost completely transparent to light. it lets the light through with very little distortion. In actual fact, that wiring is used to beneficial effect, because the wiring reduces the amount of scattered light that we have falling upon the rods and the cones. Now, you know, if it's a very bright day, you might go out and you might sort of put your hand on your forehead to sort of shade your eyes. What you're effectively doing with that is to reduce the amount of scattered light. So you're just picking up the light that's coming directly into your eyes rather than the other light that is bouncing about. And in the wires that the light is passing through actually do that job. They reduce the scattered light from bouncing around inside the eyeball. So they actually do something positive. If you're a cat, then because you are losing a little bit of light through these wires, then they have a crystalline structure at the bottom to reflect that light back up again, so that even in the darkest of nights they can still see where they're going. So when an animal needs a little bit more assistance, then the Creator gives it to them. But within that mass of wires, there are a number of structures, millions of structures, called Muller cells. Now, Muller cells run down from the very top of this area down to the rods and to the cones. In fact, there is one for every cone cell. There is a Muller cell that brings the light down through those wires directly to the Mullers, to the cone. And these are like fibre optic cables. They have got a funnel at the top that draws the light in, and they are tuned to a particular wavelength, and they bring the light down, and that light sits on top of the cone. So even though we've got that wiring, there is this special mechanism to make sure that the light can get through those wires down onto the cones. But what are those ganglion cells and the bipolar cells and the horizontal cells? Well, the light is detected down at the bottom with the rods and the cones, and then it makes the short journey up to the optic nerve at the top. But between the two, there are all these cells, and they do an amazing job. So the ganglion layer, as it's called, uses edge extraction processing to pre-process the information that is picked up by the rods and the cones. So there's 12 different, the scientists tell us there's 12 different sorts of ganglion cells, and they're each specialised in a different thing. So some of the ganglion cells will create line images of what you're seeing. So it creates an outline, like a wireframe of what you're seeing. Others will detect movement, so they'll say, okay, well there's a little bit of movement from left to right or right to left. So they're specialised in just detecting movement. And there are others that work on the highlights, and others that work on the shadow. So each is doing its own special job of interpreting what you see as a big picture and passing it to the brain in terms of usable information. So you imagine that if we want to navigate around, we're not actually that interested in the detail of what we're looking at. But what we want to know is, well, where's the space? Is there something moving? Is it moving towards us? Is there a gap that we can walk through? So this is giving us a very fast picture of the environment around us, going to the brain very quickly when we're not needing the detail of everything in terms of the colours or the fine detail of the landscape perhaps that we're looking at. So these do an amazing job, and they're sitting there directly between the cones and the optic nerve to process that information before it goes off into the brain. And it's actually said, Professor John Stevens said it would take a minute. This is a bit of an old quote because it talks about Cray supercomputers, which are a little bit old, but he said it would take a minimum of 100 years for a Cray supercomputer to simulate what takes place in your eye every second of the day. So there's an amazing amount of information. Those of us who are old enough to know what, say, Cray supercomputer is will understand how much information that will be. So when we get down to the bottom now, we've got the photopigments, the rods and the cones that give us night vision. The rods and the cones are tuned for the three primary colours. So from each of from those three primary colours, we can make up those 40 million different colours that the eye can see. Amazingly, that they are tuned just for those colours and not ones that would be irrelevant, but ones that will actually help us to be able to see in glorious technicolor. 126 million of them, so there's an awful lot. But the problem with the photopigments is that they are very quickly bleached by the light that's falling upon them. So they're detecting the light's falling on them, and they're then sending messages of what is falling on those rods and cones. But they're bleached by the sunlight, and so they need a constant source of vitamins, of chemicals, to renew those rods and those cones. So there's a great factory going on at the back of your eye that is bringing various chemicals, taking away the decayed cells and taking them out of the eye, bringing in new material for those rods and those cones to be continuously replenished. And that is done by the area that sits immediately underneath, the choroid area. And the choroid area is opaque, and it provides massive blood flow to the eye. These rods and cones are being supplied with everything it needs from the choroid area. And that's why on a human eye and a mammal's eye, those rods and cones need to be right at the back. They need to be in contact with that choroid area so that they can be replenished and renewed. But they also act as a heat sink. You see, all that light energy falling on the back of your eye actually heats the back of your eye up. But the scientists can say when the light levels in your eye increase, then the blood flow increases in your eye so that your eye is cooled. So you've got a liquid-cooled eye at the back to take away that energy. And isn't that amazing? You know, all those processes are there to make sure that the eye can do to what us seems quite simple, just to be able to look around and see. And yet it has to be in the way that it has been designed. If we put the rods and the cones at the front and we put the wires at the back, then the eye would very quickly disintegrate and not perform. In fact, obviously Dawkins says that he would like, if he was designing it, he put the wiring around the other way. Well, if that was the case, then the damage to the eye would be very quick. So our eyes wouldn't last very long. They certainly wouldn't last a lifetime. Colour perception would go because it's the colour perception that gets bleached very quickly and needs to be renewed much quicker, so that would go. We would have more distortion because the wires actually in those Muller cells draw the light down and prevent the scattered light from interfering. And when we go out in the bright sunlight, we'd suddenly perhaps have a bit of a headache because our two eyes are starting to overheat because that choroid level, that choroid layer is not in contact with the rods and cones and not able to cool it. So we can see that superficially it might seem strange how the eye has been designed. But when we actually understand all of the processes that are taking place within the eye, we can see that there has been a grand designer at work. Someone that's taken all the considerations that need to be thought about and has designed into the eye solutions for them all, so that it works, and so you and I can see the amazing things around us with the eyes that God has given us. And what does the scripture say of God's creative work? Well, in Psalm 139, let's just turn to Psalm 139. The psalmist says what our response should be when we see the complexity of life, when we see the complexity of things like the eye. The psalmist says in verse 14 of Psalm 139, I will praise thee, for I am fearfully and wonderfully made. Marvellous are thy work, and that my soul knoweth it right well or greatly. So the response that God invites us to give to him, when we see the complexity of creation and we see the complexity of our bodies, is to say, this must have been done by somebody who knew what they were doing. What a marvellous job they've made of it. He doesn't invite us to think, well, it must have all been the product of chance. So we have to make up our own minds, don't we? We have to look at the evidence and say, well, does that point towards a designer? Somebody who's thought about all of the different needs and have brought all those complex processes together in one structure? Or does that tell us that blind chance is at work? I mean, I always think, well, the fundamental question is, well, how did the brain know that there was an eye to communicate with? And if there was an eye and there was a brain, how did they know what information was going to be passed? Well, what language would they think of using to convey what the eye could see and pass it on to the brain? Without the language of that information going across to the brain, it would just be noise, wouldn't it? It wouldn't be information that the brain could use at all. Come with me to finally finish with a passage of scripture from Psalm 94. The Psalm 94 again talks on the subject of the eye. So Psalm 94. Verse 8. Understand, ye brutish among the people, and ye fools, when will ye be wise? He that planted the ear, shall he not hear? He that formed the eye, shall he not see? He that chasteneth the heathen, shall he not correct? He that teacheth man knowledge, shall he not know? The Lord knoweth the thoughts of man, that they are vanity. There's a direct challenge there by the Almighty God. And he says, well, if you acknowledge that I can make these great complex structures, then you need to acknowledge that you need to follow my ways and give me the glory that is due unto me. You see, we can choose to worship God and to follow him. Or we can choose to turn our backs on the things of God and say, all that complexity that we can see just all must have been by chance, and we can go our own way. And God gives us the direct challenge. Look at the eye, look at the ear, and make up your own mind. Is it a designer, or is it chance?